How many times have you driven by a building or structure that looks like this and wondered what it was? This is a United States Geological Survey stream gauge. The U.S. Geological Survey is a federal government agency that studies our nation's biology, geography, geology, and hydrology. Here in the Ashokan Reservoir watershed, there are 36 stream gauges, making it one of the most densely instrumented watersheds in the region.
Hello, my name is Max Kelly. I'm a watershed educator with the Ashokan Watershed Stream Management Program. Today we're going to take a drive around the Upper Sopus Creek watershed with a U.S. Geological Survey stream gauge expert, and we're going to learn about stream gauges that are housed within buildings like this.
Hi Max, my name is Donald Bonville and I am a hydrologist for the USGS New York Water Science Center.
Great, thanks for joining me today, Don. Let's learn a little bit about what stream gauges are.
And here we have auto samplers that are able to capture samples at all times of day, whether we can be here or not.
Awesome.
A U.S. geological stream gauge is a structure that contains equipment that can measure and record a stream's water level, as well as other water quantity and water quality properties. The gauges we'll see today are long-term monitoring sites that have been installed and maintained by the USGS, with funding provided by the New York City Department of Environmental Protection, as well as the Ashokan Watershed Stream Management Program.
One of the most interesting aspects of these gauges is the fact that the data is publicly available in near real-time online.
That's correct, Max. An important part of the U.S. Geological Survey's mission is to deliver high-quality, publicly available data that can inform water managers and the public on the conditions of our country's water resources. The gauges here in the Ashokan Reservoir watershed are part of the National Streamflow Network, a nationwide network of stream gauges that produce quality-assured and publicly available water level, flow rate, and water quality data.
So Don, why are there so many stream gauges in the Ashokan watershed?
Well, good question, Max. Many of these stream gauges are strategically located in areas that supply drinking water or have cold water fisheries. The Ashokan Reservoir watershed is a good example of this, with its contributions to drinking water for 10 million New Yorkers, as well as its world-class trout fishing.
That's super interesting. I think it's time we get a closer look at one of these stream gauges and see how they really work. Let's start with gauge height, which is another name for the water level of the stream.
Gauge height is determined by measuring the physical height of the water above a reference point, known as a datum. The U.S. Geological Survey scientists have many methods to determine this value, all of which can be useful as conditions at a site change. We should note, though, that gauge height is not the same thing as stream depth. Gauge height is a value assigned to a water level and is based off of a surveyed reference point, such as we have here a bracket on a bridge abutment or something else that is fixed in place and unlikely to move over time. Stream depth, that is the depth of water over the stream bed. The stream bed is not typically used as a reference point for gauge height because the stream bed can change over time due to erosion and deposition from large storms.
And I seem to remember that discharge is determined by multiplying cross-sectional area of the channel by the velocity for a given period of time. And I remember that gauge height is needed to determine discharge, but how does a gauge measuring water level at a specific point in time determine discharge for an entire stream reach or river?
Great question, Max. So simply put, that is correct. Discharge is determined by multiplying the stream cross-sectional area by stream velocity per unit time. The U.S. Geological Survey determines discharge using several steps. One, we continuously measure the water level, or also known as stage. Two, we come out here periodically and take cross-sectional discharge measurements. Three, we develop a relationship between those measurements we come out and take and the continuous recording of gauge height. And then finally, we go back to the office, we apply the relationship that we were able to make, and we apply it to all the gauge height data that we collected. And we use that to compute discharge. The U.S. Geological Survey then reports this discharge in the units of cubic feet per second.
Wow, that was really helpful. The U.S. Geological Survey is such a key partner in monitoring the quality and quantity of water in the Ashokan Reservoir watershed. And it's just so amazing to me that in small subwatersheds like the Stony Clove, there's 19 instruments there that are monitoring continuously in such a small area.
Yes, so throughout the Ashokan Reservoir watershed, and especially in Stony Clove Creek tributary, one of the largest water quality concerns is turbidity. Turbidity is an optical measure of water that can be used to describe water clarity. Turbidity in the streams of the Ashokan Reservoir watershed is often the result of the presence of suspended sediment.
And that's usually clay, correct?
Correct. Geology in the Ashokan Reservoir watershed is typically rich in high clay content glacial legacy sediments that can be present in stream beds and stream banks. Localized erosion of exposures can result in stream water that appears very cloudy or turbid. Historically, Stony Clove Creek has been a large producer of turbid water, especially after damage caused from flooding caused by Tropical Storm Irene in 2011. The 19 monitoring gauges the U.S. Geological Survey operates in Stony Clove Creek are intentionally located to identify where sources of glacial legacy sediments are negatively impacting water quality and making the stream water turbid.
For a drinking water reservoir like the Ashokan, turbidity is a primary concern. Turbidity decreases the effectiveness of the UV disinfection process that ensures that unfiltered water is free of pathogens. To combat this and maintain this pristine water quality, New York City has chosen to invest in stream management programs who take action to mitigate the sources of water quality impairment. So here we have a little bit of clay, and Don and I are just gonna move it around in the water and see how much effect that little bit of clay has on turning this pretty clear pool into something that's rather turbid. You can just watch as the pool becomes more and more brown from the clay. And this is just a little bit that we had on our hands. There are entire sections of stream where hundreds of feet of exposed clay is present, so you can imagine the effect that that has. We are now downstream of the Panther Kill restoration site. The Ashokan Watershed Stream Management Program completed this stream restoration project in 2022 to reduce turbidity inputs from glacial legacy sediments that we just talked about.
The USGS installed gauges both upstream and downstream of this project site to monitor the overall effectiveness of this stream restoration project in reducing turbidity at this site. Preliminary results suggest post-restoration turbidity levels are reduced at mid and high discharge conditions compared to pre-restoration turbidity data.
The Panther Kill restoration is one of many stream restorations that have been completed in the Ashokan Reservoir watershed to address point sources of sediment that result in turbid water quality. One benefit of being located in such a heavily gauged watershed is that the data allows our staff to know about new areas of elevated turbidity without having to search the entire watershed by foot. New sources of sediment that result in elevated turbidity can often arise following large storm events. It's super helpful to be able to see instantly where those pop up instead of having to search around on foot. Saves a lot of time, saves our knees.
That's great, glad we can help.
One of the many things that the Ashokan Reservoir watershed is known for is the fish populations. Stream temperature is an important stream property for the health of certain fish species. The U.S. Geological Survey gauges are also able to provide us with water temperature data, right, Don?
That's correct, Max. Our Esopus Creek gauge at Coldbrook measures water temperature at 15-minute intervals. The U.S. Geological Survey typically collects water temperature data by fixing a thermistor underwater in a well-mixed section of the stream. To assure the accuracy of the in-stream temperature equipment, U.S. Geological Survey scientists regularly take comparison measures with a calibrated field probe, as well as cross-section temperature measurements to confirm that that point measurement from the in-stream equipment is reading a temperature that is comparable to the temperature across the whole stream.
That is excellent. My friends at the local Trout Unlimited chapter use temperature data to inform their decisions on how to fish responsibly. In summer months, as the water temperature increases, the amount of dissolved oxygen in the water column decreases. Similar to how we breathe air, fish also need oxygen. However, fish absorb dissolved oxygen while underwater through their gills. When water temperature exceeds around 68 degrees Fahrenheit, temperature-sensitive fish species such as trout struggle to absorb enough dissolved oxygen to counteract their energy expenditure. When fighting a fish on your line, the fish has to expend a lot of energy. This increased energy expenditure combined with the background levels of stress from high water temperature can lead to mortality after the fish is released.
So this is one of our data logger setups. So the water temperature probes, the turbidity probes, our auto sampler, the solar panels, telemetry, all of that goes back into our data logger, which basically handles all the programs, stores all the data, and is an essential piece of equipment that we couldn't do this without. This is a wire weight, which is used to basically just give us another method of confirming what water level is. And so right now, I'm reading 3.48. If we go back in the Gage box and look at the electronic version of this, it should be pretty darn close to that. And like we mentioned earlier, U.S. Geological Survey data is publicly available. Anyone can go online to the U.S. Geological Survey's Water Data for the Nation webpage and find a wide range of daily and sub-daily data, like the 15-minute water temperature data your Trout Unlimited friends use.
AWSMP staff use this near real-time data for several applications, and our staff watch the Gage data closely during high flow events. Stage and discharge data can tell residents the magnitude of ongoing flood events in near real time. AWSMP has created quick reference guides for Olive and Shandaken residents to relate USGS gauge information to storm severity. We relate the gauge height to flood recurrence interval, and this is a helpful tool in the flood preparedness toolbox. Additionally, this can be useful to direct resources in a post-flood environment by determining sub-watersheds which were most affected by high flows.
Max, these are great examples and uses of data from our gauges.
Don, thank you so much for coming out to the Ashokan watershed today and for taking the time to explain the intricacies of U.S. Geological Survey stream gauges. We hope that this video was informative and that everyone can come up with their own ways to engage with USGS gauges.
Thanks, Max.